So we're going to be presenting Radare2, which is a open source reverse engineering framework and toolset. So let's see.
We were accepted to the NUDUAC, but unfortunately it's today, so we couldn't make it. We're a little bit sorry.
So my name is Jeffrey Crowell. I am a software engineer at Google. I work on things completely unrelated to Radare2. If you know me, it's probably from CTF. I play for Shellfish, and I run the Boston Key Party CTF.
I'm Julien voisin. I'm soon to be graduated, and so I'm looking for a job. And you can find me on do3.org. And like my friend that spoke this morning, Paul, I've got a funny French accent.
So in most reverse engineer toolbag, if you're a professional, it's most likely IDA Pro, ImmunityDebug, or WinDebug, or your top three tools. If you're an amateur, it's probably also IDA Pro, WineDebug, Hopper, or OllyDebug. But for amateur, I'm pretty sure that almost not everyone was working at a certain antivirus company in 2011. Either you're using WineDebug or your Windows is probably pirated. Hopper, maybe, probably not. And OllyDebug is kind of defunct. I don't think anybody is still developing this. So why is IDA Pro in everyone's tool bag? It's like the de facto reverse engineering tool. It's created by Ilfak. It's first was from Data Rescue and now Hexrays. It's not open source. It's not really affordable. This is why amateurs don't use it. Almost every architecture that you could want is supported, and it has this magic bullet, the decompiler. It's overall an awesome piece of software, and we're trying to make something equally awesome.
This talk is not about trashing IDA, to be clear. We just want to build an alternative. We're both IDA users. So it's my time. So Radare2. Radar started in 2006 by a Spanish guy named Pancake. It was a forensic tool, an hexadecimal editor, and he completely rewrote it with some friend of him in 2009. It's completely in C, so it's really portable. You can compile it on anything you want. And there is a shitload of C lines, and it's LGPL, so you can embed it in your proprietary software and sell it. It's a multi-purpose suite of tools. It's not only a decompiler or only an assembler. You can do really a shitload of things with it. It's likely packaged in your favorite distribution, which should be Debian. But you could also install it from source because we are moving really fast. For the last release that happened a couple of weeks ago, we've got more than 50 contributors, so it's not a shitty software written by only one guy in his house. We are many people behind it. We did a Radar Summer of Code because Google rejected it, so we just say, fuck you, we're going to make our own. I say that it was a suite of tools, and now we are going to detail them a little bit.
So R2 comes with a large suite of tools. All of them, their names are relatively descriptive of what they do. So some of the included tools are REg2, which is a front end to a shellcode compiler, which is called REg. It can compile programs into tiny binaries, generate shellcodes, just generally what you would expect out of a shellcode tool.
Rediff is using for binary diffing, so you can have this sexy view with the graph and the highlight part that are different.
REbint2, it's a binary program info extractor. Basically, if you're familiar with readup, this is a similar tool, although it will work on any binary that R2 works on, so PE, ELF, just Mach-O, basically anything R2 can understand, REbint2 can understand.
Refind is used to search patterns in file, like you can use it when you are reversing firmware, for example.
hash2 is a block-based hashing utility. It can do MD5, SHA-1, SHA-256. Basically, if you want to compute hash on blocks of a file or an entire file, it can do this.
Radare2 is pretty useful when you're doing CTF, for example, because you can run program in exotic environments, like you can redirect std in, std out to socket, or put some weird UID on it, or whatever. It is meant to control completely the environment of the binary execution.
RESM2 is assembler, disassembler. It's like the most useful part of R2. It's for assembling, disassembling of various architectures. I'll explain later. It's pluggable, so if R2 does not include the architecture that you like, it's very easy to add a new CPU module.
Rax is some kind of calculator because you may be tired of spawning a Python shell every once you want to have hexadecimal value and decimal value, so just use Rax2.
And Radare2 is basically, it combines all of the previously mentioned tools into one hopefully useful CLI.
Hopefully. It runs on almost everything, ranging from Windows to Linux to BSD to your web browser to QNX to Android and even some smartwatches. And I know that there are some Tesla people in the room. We actually managed to run Radare2 on the Mazda car. So if you want us to run it on Tesla, come talk with us.
So Radare2 can do lots of different file formats, like Windows file formats, PE, MZ, can do ELF, 64-bits ELF, OSX file formats, Mach-O, Fat Mach-O, Java, DEX, basically lots of different types of binaries, including some ones that you might not ever want to use, like Plan 9 or...
We've got a contributor that is really a fan of Pokemon, so he's adding support for every type of Game Boy that you may know about, like Game Boy Color or DS or whatever. And this is the funny part. We support BrainFuck. We've got a working BrainFuck debugger. Or the DCPU16 or Game Boy or Dalvik or some architecture that you don't even know about. Like a shitload, Malboji or the... actually, I think that you did a challenge for the Boston Key Party implying the TIS format.
Yeah, the RVM.
You may want to speak.
So RAR also implements its own VM. It's basically specified for the RAR file type, which is like similar to zip or 7-zip or something. And it has its own VM, and R2 can be used to debug or decompile or disassemble this.
And it was present in a Boston Key Party CTF 1 year. We also support Spark, Whitespace, Propeller, and Z18 or whatever. So we support really a shitload of architecture. If your favorite one isn't listed on the slide, come talk to us and we'll help you to implement it in Radare2. More about Radare2 internals.
So at its heart, R2 is generally exposing itself as a library. So you can write C, you can write anything and hook into the R2 shared objects. We also have Swig and Valabind, so you can use directly from Python, Ruby, a few other Vala, a few other languages. So it's generally pretty easy to build your own tools on top of R2. So you can reuse analysis features, disassembler features, things like this. But bindings are pretty boring. It's much more difficult to call into these libraries. It takes more effort. If you want to do something very quickly, we have something called R2 pipe, where you basically can spawn R2 in the background and issue commands to it. A lot of new tools are being built on this, or like quick things for CTF or quick tools. Things like Bakken, which is a GUI from, do you know who makes this?
A Spanish guy.
Spanish guy, is based on this. So we have packages in Ruby gems, Python pip, Rust crates, basically.
The Perl stuff too, I think.
Perl, Go, basically any language that you'd like to use for scripting, we probably have an R2 pipe for this.
Also, it can split JSON. So if you don't want to pass Radare2 output by hand, you can just ask for JSON.
So R2 is pluggable. So as I mentioned before, you can write very simple plugins to add a new CPU. So you can add like a assembler and disassembler, code analysis. So we have, for every opcode, we can have like the type. So you can say this is a stop or a move, something like this. The registers that are available on the machine, the syscalls that are available for a system, the debugging layer, new stuff for search, new stuff for I/O. Basically anything that you would want to add for a new architecture, you can write a plugin for this.
Feature comparison, because this talk is entitled Building an Alternative to IDA, so let's compare them. IDA is a great book, and Radare2 is self-documented, but we also have a book. R2 is like Vim. Are there any Vim user in the room, maybe, or Emacs, or? Okay, at least I'm not alone. For example, you can see on the screenshot that the thing that was typed is IA question mark. A stands for analysis, the second A for all, and question mark because you want the documentation. So once you have used the command once, since they are pretty logic and intuitive, you can remember them. Just append question mark everywhere. Every single command in Radare2 is documented this way. IDA is some plugins, and we've got more bindings. Yeah, we should have written bindings, I don't. Yeah. Python, Node.js, Lua, Vala, Lisp, OCaml, whatever you want. We've got really a shitload of bindings in R2 pipe. Even Node.js, I don't know why. IDA has some graph, and R2 does, but in ASCII art. We don't have a sexy GUI. We have some shell. And one day your great Spanish leader woke up and implemented this. There is also a minimap. If you don't care about the instruction and you just want to show the graph, you can. It's debugger compliant, so you can step into the graph. And it's completely interactive. You can move the graph around. And this is really great, I think. IDA don't have this. IDA is clever and interactive, and R2 is mostly interactive. You can do anything you want. You can tell anything that you want to Radare2. We're mostly using it for CTF, so we don't really care about analysis, powerful analysis capability. We just want it to be interactive to deal with whatever we want. So you can leave comment, name, mark everything, modify, blah, blah, blah. You can see that there are some arrows. Those are jumps. There are some import symbol decoding, cross preferences, anything that you want. Most of the time it's already implemented in Radare2. Well, we don't have a GUI yet. No, actually we have some GUI, but they suck. They're work in progress, I mean. And yeah, but actually it's not that scary. We've got a visual mode. It's a little bit like the TUI stuff in IDA Pro, but in a more modern way. And we've got Vim-like key binding, as I said previously, with AA or question mark or whatever, or P for print. If you want to show a function, you just have to hit P for print, D for disassembly, F for function. It's not that hard. We've got a web UI, because I don't know why, but it can be used for collaborative reversing. For example, you can launch Radare2 on your iPhone or your iWatch stuff, and debug it from your laptop using the web UI. So this is pretty cool. And you can communicate over R2 pipe. So for example, you can spawn an application on your iWatch, and your friend at the other end of the world can debug it on his computer. That's pretty cool. TUI mode, we've got a better one. No, more seriously, it's like a little bit like NQSs. And it can be used, if you don't like the shell, you can use the visual mode. It's like a GUI, but in your shell. And for example, here you can see the configuration part of Radare2 in the ASM thing. So you can hide cross-references, use tabs, change the syntax for AT-AT. And you've got the preview in real time. That's pretty sweet. We've got a web UI. It's a pretty complete one with some, it has the IDA key bindings, so you won't be lost. There is the minimap, there is some interactive graph, disassembly, functions, symbols, whatever you want, but in your browser. IDA has a debugger, so do we. It has everything that you might expect from a debugger. It works in visual mode, so this is the visual mode. It's a little bit like PEDA, if you know about it. It was presented at Black Hat, I think. And it's a mode for GDB. And you've got the stack on top, the register, and the current listing. You can see the here IP. So it's pretty cool. And we've got several backends. You can use GDB from Radare2. You can use WinDBG, the VMware stub, and you can even use WinDBG, the Windows stuff. So you can debug your Windows driver using Radare2. IDA has some great analysis, and we've got analysis. Function detection, blah, blah, blah. Flirt, the IDA technology to recognize function, it works in Radare2. So you can just apply your signature, and it works. And we've got signature. To call them, you have to press Z in Radare2, like signature. And it's a little bit like Flirt, but the Radar way. Cross-references, we also support the dwarf debugging symbols and PDB with automatic downloaded. So you can see that there are some symbols that I recognize, set local or exit. There are some internal representation language in IDA and also in R2. It's called ESIL. It stands for Evaluable String Intermediary Language, something like that. Yeah. It's RPN-ish, so it's awful to read, but it's documented and it's easy to write and to parse. This is some excerpt of ESIL, and it's currently used for emulation. We've got some kind of emulation working that is pretty useful for CTF or to pawn some keychain or track me. And it's currently used also for the compilation and maybe later for analysis. We've got 2 Google Summer of Code students, thanks to the Open World project. They're currently working on the compilation, and we'll talk more about this later. There are some cool plugins for IDA to pawn stuff, but in Radare2 it's in core. This is a screenshot of our Rob Gadget Hunter that work with regular expression. So I'm looking for pop R1 and 1 character. So it yields pop, pop, pop register. We also do some emulation, as I said previously. We have the pattern, the magic stuff from Metasploit and Mona too. Mitigation, detection, environment control with the what's the name of the Raran? With Raran. And some reject drop and stuff. Same for binary diffing, we support it. You can see a diff between bin true and bin false. And the only part that is changing is the end. There is a XOR AIX on the left and a move AIX1 on the right. So, summary.
So, where are we currently with R2? So currently we have students who are working with the Google Summer of Code. They're working on a new intermediate language, which is called Radare2, which is going to be the basis for our open source decompiler. We're working on getting everything to be more stable and faster. So we have a key value store, which is currently not used for most things, but we expect that once this is more in use, everything will be much faster. We just had a new release of 0.9.9 in June, which was just a few weeks ago. Hopefully you shouldn't be using that, and just use it from Git though. We're having a second edition of the Radare2 Summer of Code, which is going to be starting, I think, next week.
Yeah, I think so.
And in general, about 1,000 lines of code are modified each week, so we're moving very quickly. New features are being added all the time, general improvements all the time. It's pretty exciting stuff. So the drawbacks are, compared to IDA, we have a super steep learning curve. The user interface is not generally friendly to new users. We have a lot of features, and almost nobody knows how to use all of them. The targets are very fast moving because new technologies are made all the time. There are tons of great binary analysis tool chains, tons of great tools for all of this, and to keep up with these features is pretty tough. And IDA is generally a much friendlier tool for people that are both used to it and new users. But we have a lot of benefits. So as being a free software project, anybody can contribute, anybody can read the source, anybody can add new features. We have a great community. We have, in our RSC channel, we have over 200 people. We support a lot of exotic architectures, maybe ones that IDA doesn't support, maybe ones that you want to implement yourself. With very active development. So, like I said, there's 1,000 lines that are changed every week. Lots of new features are added all the time. And our user base is increasing very rapidly. So we have this amazing tool. Who actually uses it? So some of the best CTF teams in the world use it. Shellfish, we use it. I've seen some write-ups from the Dragon Sector team using it. Some popular reverse engineering projects like Coreboot or Magic Lantern, the firmware for cameras, use it. There have been write-ups from anti-malware companies like Alien Vault or IO Active. And a lot of war games have it installed on their thing, like Smash the Stack IO and Over the Wire have them installed by default. So we use it. I don't know if you do, but maybe you should give it a try. So the future plans are mostly working on analysis and decompilation and emulation. So as you know, we have ESIL, which is our intermediate representation for emulation. Currently, we can emulate most things in x86, ARM, Game Boy. There are still some functions missing and some syscall stuff is missing, so we're working on getting this to 100%. Decompilation, we're in a very early stage for this, but we expect to have something usable relatively soon. And one of the major features that everyone wants is a GUI. We don't have this. It's something that might be made soon, might not be. Basically, whatever the users want and whatever the developers want is what goes in first. And if you want these features, let us know. So in conclusion, IDA is the #1 tool right now, but we should question this. Everyone shouldn't be using the same tool, and don't be pirating IDA.
Radar is nice and you should use it. No, at least you should try it. We've got some resources like a TV channel, some blogs, source code, and we're really super active on IRC. And feel free to talk to us if you want to get used to Radare2 or whatever. Thank you very much for your attention. Do we have some time for question? Maybe 2 questions, yeah. There are no questions. Oh, there are 2 questions actually. Great. Maybe you can yell, I can repeat the question for this week.
So we store things in a project file, and you could delete the functions from the project file. Undo is an overrated feature anyway.
Yeah, it was working, I think.
Is it working? No.
No.
Right. 1, 2, 1, 2. Yeah.
Yeah.
So thank you for the presentation. I was wondering, IDA has like 15 years of existence. Maybe you should strive to differentiate and try to have something that IDA has not, and not try to replicate IDA, because, well, you probably have the resources to reach the point that where you can compete with IDA. And you mentioned something that's really interesting where IDA is really bad, is for collaborative reversing. So maybe for Radare, for example, you could work on the collaborative reversing part using the web UI. That would be really awesome, I guess.
I don't have enough money to afford IDA, so feel free to offer me a copy of IDA.
Yeah, that's a good point too. Thank you.
Okay, thank you.